Hello and welcome to today's lesson. In our last lesson, we learned about the area. We introduced the concept of area, and we defined area as the amount of surface that is occupied by a two-dimensional figure. We said given a rectangle, when we talk of area, we mean the space inside this rectangle. And we looked at the rules of calculating different areas of different shapes. For example, we said if you want to calculate the area of a rectangle, you use the rule length times base. While for a triangle, we said you calculate using this rule, which is a half base times the height. While the square, you calculate the area using the rule L squared. Now, today I want us to learn about finding the areas of special quadrilaterals. These are four-sided figures apart from the rectangle and the square. Under these special quadrilaterals, we have a parallelogram. A parallelogram is a tilted rectangle. We have two opposite sides, equal and parallel. If you are supposed to find the area of a parallelogram, how are you going to go about it? We shall develop this rule from the area of the rectangle that we learned earlier on, and also from the area of the triangle that we learned. Having these rules is very important because, as we said in the last class, that instead, if we have composite figures, sometimes you are asked to divide into basic shapes and then calculate the area. Then you add the areas forming that particular composite figure. That could be cumbersome. But if we have the formula or the rule of calculating the area of that composite figure, then it can make our work easy. Let's see how we can come up with the formula or the rule of calculating the area of a parallelogram. If we drop a line, a perpendicular line to this, to the length, you realize that they will form, a triangle will be formed at this far end. This triangle, we can take it and put it here. If we take this triangle that we are forming, if we cut this triangle from here and transfer it to this position, what will we have? You realize that we'll have a shape of this nature. What do we call that shape? This is a rectangle. So what is the formula or the rule of calculating the area of a rectangle? Length times the base. So we are saying, you realize that the only thing that looks extra in the parallelogram is this triangle A, which we can transfer it here. And you realize that it will form a rectangle. Then what does that mean? If this is the height, which is like the base of the rectangle, and this is the length, then we can calculate the area of a parallelogram by saying length times the height. This is the length and this is the height, the perpendicular height. Length times the perpendicular height gives us the rule for calculating the area of a parallelogram. Simply because we realize that this triangle, this parallelogram can be written in a particular manner and it will form a rectangle. So we are not adding anything. We are just transferring this to this particular end and it will form a rectangular figure. So that means the rule of calculating the area of a parallelogram is the same as for calculating the area of the rectangle. But in this case, we are not going to be saying this is the base, but we are saying it is the height because it is a perpendicular distance to the length. So that is how we can then be able to calculate the area of a parallelogram. The second figure, special quadrilateral here that we look at today, is the rhombus. How does a rhombus look like? A rhombus is also like a tilted square. If you tilt a square towards one side, but then still, the opposite sides are still parallel, then you will have a rhombus. Because it's like a square, all sides are equal. All sides are equal. So for a rhombus, if we drop that line from this point to this end across the rhombus, what do we have? We call it a diagonal. So a rhombus has two diagonals. Let's call this one going this way x and this other y. So the rhombus has y, the diagonal y, and also has the diagonal x. If we again try to draw the rhombus using the method that we used earlier on the parallelogram, let's see the figure that we can come up with. So this is a rhombus. If we can redraw it, if we drop these lines here, the dotted lines, you realize that this, if we take this one, can come there, and this other triangle here can come here. What will be our end figure? We'll have a figure like this. You realize that if we take this shape here and you take this other shape here, we'll form a figure of this nature. We will not be adding, only that we are transferring this triangle to this space. It will cover this space. This triangle here will cover the space here. And the figure that will be formed will be this nature. So you realize that x, the diagonal x, will be twice, it will be longer. It will not fit. The whole of x, the diagonal x, will not fit to our new figure. It will be extending. And it will be extending by a half, because this is the part that is we are cutting away. If we cut out this part, we are cutting a half of x. So then how can we calculate the area of our new figure here? this is saying that this is x. The whole of this is x from here to here. That means also it is, if we are supposed to get from here to this point here, then that will be a half of x. That will be a half of x, because we will not take the whole of x inside the figure. But here, it will be y. So then what will be the area? Our area will be a half x times y, which is a half x y. That is how to find the area of a rhombus. Remember, x was the diagonal from this point to this point, and y is also the diagonal from this other end. So we are saying, to calculate the area of a rhombus, we say a half times x, which is one of the diagonals, times diagonal y. So the rule of calculating the area of the rhombus is a half diagonal x diagonal y, which is short half x y. Remember that x and y are the diagonals. Our next special quadrilateral, a four-sided figure that we want to understand today, is a kite. Kite has two isosceles triangles joined together. It has the upper isosceles triangle, meaning the two sides are equal, and the lower one, the two sides are also equal. So if we join these two triangles, then it will form a kite. A kite has also diagonals. It has diagonal x, let's call it x for now, has also diagonal y. Let's see if we can redraw the kite and see how we are trying to develop the rule of calculating this special quadrilateral. If we can rewrite, you realize that this triangle here can come this side, and this other triangle will come here. If this triangle comes here, and if we take this triangle here, what will be our new shape? Will have a shape of this nature also. Again, you realize that if we draw it this way, this is the part that we are carving it out. So again, you realize that x, we will not be able to accommodate the all of diagonal x inside. It will still, there will still be a part that is remaining. And the part that is remaining is x. And we have y. Sorry, this is y being the base. So again, if we are supposed to calculate the length, the area of this new figure, what are we realize that it is forming a rectangle. So for us to be able to calculate, then this x has to be divided into 2 because it's not accommodated. The one that is remaining here will be a half x. So to calculate the area, we say again, I have x times y, which will give us a half x times y. And remember, our x is diagonal x, the diagonal of the kite, and the two diagonals of the kite, diagonal x and diagonal y. So we are saying, again, the area of the rhombus can be calculated using this rule, a half x times y. You must have realized that this is the same rule that we use to calculate the area of the rhombus. So what are we saying? The rule for calculating the area of the rhombus is the same as the rule for calculating the area of the kite. Our other special quadrilateral that we will look at today is the trapezium. How do we come up with the rule of calculating the area of a trapezium? A trapezium is so a trapezium has two opposite sides parallel to each other, and it also has a height. We remember we said the height is perpendicular to the length. The height is always perpendicular to the length. So that is the trapezium. You realize that the trapezium has several. If we drop a perpendicular line here, it has a triangle here. It also has another triangle here, and at the middle, it has the rectangle. If you were to use the basic shapes to calculate the area, then we'll calculate the area of this triangle, the area of the rectangle, and then the area of this other triangle separately, then add them together to give us the area. But you realize that is cumbersome and takes a lot of time. We can come up with a rule that will save us time in calculating the area. So let us again try to redraw our trapezium. You realize that it has if we rewrite, then we have two triangles, the first one and the second one. How do we calculate the area of these two triangles? So assuming this is A and this is B, the two opposite and parallel sides, A and B. If you remember, in our last lesson, we have just said that the area of a triangle is calculated using the rule a half base times the height, which in our case area of triangle 1 will give us a half AH. Area of triangle 2 will give us a half BH. So now we have the two areas, the area for triangle A and the area for triangle 1 and triangle 2. For us to get the area of the whole of this figure, we add the 2. We add the areas of the two figures. If we add, this is what will give us. You realize that we are not going to proceed in adding the 2 because they are different terms. But what we can do from there is to factorize, to identify the like terms, the common terms, to identify the common terms. And you realize that a half is found on both sides. And also, H is a common term. If we take this outside the bracket, a half H, then here we remain with A plus, here we'll have B. What do we have? A half H into A plus B. That is the total area of this trapezium. So then this is what is our rule now for calculating the area of a trapezium. A plus B. A and B are the two opposite and parallel sides of the trapezium. And H represents the height of the trapezium. So what is the rule for calculating the area of a trapezium? A half times the height times into A plus B, which represents the two opposite and parallel sides of the trapezium. Now, let us look at the examples of how we can use the rules that we have just developed to calculate the areas of special figures. So let's look at an example. We are given this figure and we are told to find the area. First of all, you're supposed to identify which figure is this. What is it, class? You realize that it is a parallelogram. And a parallelogram, we said, you must always write the rule. You must always write the rule so that you don't confuse when substituting values. So we substitute the values, length times base, which is 5 meters times 1 times 2. It will give us 6 square meters. Remember, we are still calculating the area, and we said the units of area is square meters. So then what we now have is 6 square meters. The area of a parallelogram is given in square units. Then so let's look at this figure again. What is this figure? You realize it is a rhombus. A rhombus, how do you calculate the area of a rhombus? It is a half times diagonal x times diagonal y. a half x, y. So again, we are supposed to identify, to come here in our figure, identify the diagonals, and then substitute in the rule. So you realize one of our diagonals is 5 centimeters, and the other is 3 centimeters. What will that give us? 2 goes into 5, 2.5 times. Again, the units are square, so the answer will be 7.5 square centimeters. Given what do we call this figure? This is a kite, and we said the rule for calculating the area of a kite is the same as the rule for calculating the area of the rhombus. And that is a half times diagonal x times diagonal y. So then identify the diagonals in this figure. So we are told that one of the diagonals is 30 millimeters, and the other one is 20 millimeters. So our only work to do is to substitute in the rule. A half times 20 millimeters times 30 millimeters. 2 goes into 20, 10 times. And that will give us 300 square millimeters. Let's look at this other example. We are given this figure here. Let's identify the figure first. Which figure is this that we are given? You realize that two sides are parallel. Only two sides are parallel, and this is called a trapezium. So we said, what is the rule for calculating the area of a trapezium? We said the rule is a half times height into A plus B. And if you can remember, we said A and B are the two opposite and parallel sides of the trapezium. We said it is very important before you calculate, you write the rule. And you must understand the figure first, what it is, write the rule, and then substitute the values in the rule. So let's substitute. What is our height? Our height is 5. What is our A? Either of the opposite sides. This is 9. B, the other side that is parallel and opposite to each other. Now, we are supposed to start with the values in brackets. We are supposed to start with the values in brackets. So we are supposed to add these two values, first of all, in the brackets. And what we have? We substitute the brackets by multiplication. because it means the same. So we get the value in the bracket is 13, so we write here. This also means multiplication. Then now we can do the calculations. 2 goes into 5, 2.5 times. Then 13 times 2.5, that will give us so again, remember to indicate that these are the square units. What will give us will be 32.5 square units. So those are the examples of how to calculate the area of special quadrilaterals. Now that we have the rules, we just simply substitute the figures or the values into the figure into the rules that we have already established. What if you are not given the numbers instead? You are given the letters. You are given the letters instead of numbers. The rule will still apply, only that instead of using the letters, the numbers, we use the letters. An example is given an example and you are told to calculate. You are told to calculate the area of this figure. Again, this is a trapezium and we use the formula a half times height into A plus B. So because we already have height, we are told the height is H, and one of the sides is N, and the other side is M. We only substitute using the letters that we are given into the rule. We will not substitute H because it is indicated as also H. So the only thing that we will do is to substitute A with N and B with M, and this will be our answer. We cannot be able to proceed from here because they are not the like terms. They are not like terms. So this will be the area. You will leave the area at that. Finally, let's look at this question on the same. Let's look at this question. Would you use the formula a half x to find the area of the rhombus? Explain. So from what we have learned, a half x times y is the formula for calculating the area of rhombus and the area of a kite. So the question is, can you still use this one? Is this rule applicable in this figure? Let's check. X X is the diagonal and Y is the other diagonal of the rhombus. Are we given the diagonals? The diagonal will run from here to here and from here to here. Are we given the diagonals? You realize that we are not given. So that means we are not going to use this formula to calculate the area of the rhombus since the diagonals are unknown. But we can still calculate the area of the rhombus using the information given. Which information is given? We are given the height and we are given the base. That rule is for calculating the area of which figure? You realize it is the area, the rule for calculating the area of a parallelogram. So we will apply this area, this rule for calculating the area of a parallelogram, because a parallelogram simply means a figure that has two opposite sides parallel. This one, rhombus, also has two opposite sides parallel. So we can still use the formula for calculating the area of the parallelogram. So in this case, we only need to substitute the values in the formula. Which will give us 8 times 10, 8 for the height, 10 for the base. That will be 80 square centimeters. That will be the area of this figure. As a proof to the formula that we have already, the rules that we have already discussed, let's see if it will agree with, if we follow a different method to be able to get to that rule. Let's try to find the area of a rhombus by dividing it into 4 equal triangles and see whether if we use the 4 triangles, we'll be able to get still the rule for calculating the area of a rhombus. You realize that we have now the 4 triangles, triangle A, B, C, and D. Let's find the area of triangle A. Area of triangle A, this is the base, which is half x, multiplied by a half y, which is the height. That is the area of triangle A, because we know that the area of a triangle is a half base times the height. So if we substitute the base, which is a half x, and the height, which is a half y, what will that give us? what we will have, sorry, this is a half for a half. We left out the a half for a half base times the height. So we will have 1/8 xy. That is the area of A. The area of A. And you realize that we now have 4 equal triangles. What are we supposed to do so that we get the area of the whole figure? Because they are equal, we multiply by 4. You realize that it will give us still a half xy, which is the rule that we had developed earlier on. So that means the rule of calculating the area of the rhombus is true. Now let's move on and understand how to calculate the area of a circle. Yesterday we said, or in our last lesson we said, that a circle is a round shaped figure which has a radius, which is a half of the diameter. This is diameter, and it has circumference, which is the distance all round the circle. So let us today look at how to calculate the area of the circle. Again, it has been found out the way we discovered the other time in our lesson that area of a circle over its radius will give us a constant that is called pi. That's called pi. We did some calculations in our last lesson, and you realize that circumference over or divided by a diameter was also giving us the same constant, which was pi. It is also the same for area. So if we are supposed to calculate the area of a circle, sorry, this is squared. The area of a circle is calculated using the rule pi r squared. Pi r squared. The square of r, this is r, which is the radius, and this is the pi. So that will give us the ratio. If this is the rearrangement of this ratio, area over the square of radius, which gives us pi. So if we bring pi if we want to make pi the subject of the formula, what do we do? We multiply both sides by r squared. And that will give us pi r squared for the area of calculating the circle. Remember, this time round we'll not be using the diameter, we'll only be using the radius to calculate the area of the circle. If we are given a half of the circle, how do we find the area of a half of a circle? Half a circle is called semicircle. And for you to be able to find the area of a semicircle, because this is a half, you multiply a half by the area of the whole circle. Area of the semicircle, because this is half of the circle, and if we say pi r squared, it will give us the area of a full circle. We then multiply by half to give us the area of that particular semicircle. You realize this is a quarter of the circle, and a quarter of the circle is called a quadrant. How do we find, it also has a radius, it is curved from the full circle. This is the radius. So it's curved from the circle. It's a quadrant. How do we get the area of a quadrant? You realize we have said it is a quarter of the circle. If we say pi r square, that will give us the area of the full circle. So we are supposed to multiply by a quarter so that we get a quarter of the circle. So the area of a quadrant is given by a quarter pi r square. Now let's look at examples of how to calculate the area of a circle. Let's calculate the area of this circle using pi as 22/7. The most important part, we are saying we always write the rule. Area is equals to pi r squared. Then now we substitute the values in the formula. Because our radius is 7 meters, and we are saying this is pi. Pi is 22/7, so we put 22/7. R is 7, and R is squared, so we multiply by itself 2 times. Then you realize that 7 goes to 7, 1. Then we'll have so the area of this figure is 154 meters square. Let's look at another example. Calculate the area of the circle using pi as 3.14 in a decimal place now. And we are told that the radius is 10 meters. Again, we write the rule, which is A, or area, is equals to pi r squared. Use the pi that you are given. It is very important to follow instructions. If you are told to use 3.14, use 3.14. So we'll have 3.14 times 10 times 10. Our 10 is the radius. Radius is multiplied, is squared. So it will give us, the answer is 314 meters or square meters. What if you are asked to calculate the area of the circle using a calculator? Calculating the area of a circle using a calculator. The radius of this circle is 2 meters. Again, write the formula or the rule, which is pi r squared. So this is the formula of calculating the area of the circle. We are supposed to use the calculator. In your calculator, check for the button that is written pi. Locate the function, the button written pi. When you find that pi, press it down. Then multiply by 2 squared. Or press the button of pi, then multiply by 4. You can do this, the calculations of the 2 first, the 2 squared, and you will get 4. So then press the button of pi and multiply by 4. That will give you 12.57. That is to 2 decimal places. So you can also be able to calculate the area of the circle using a calculator by pressing the button with a pi, then you multiply with 2 squared. After pressing the button of 2, press the button of square, and it will give you 12.57. Let's look at this shape here. The shape is a quadrant, and we have said the rule for calculating the area of a quadrant is, don't forget a quarter. This is a quarter, pi r squared. We substitute our radius. This is our radius. This is our radius. Our radius in this case is 3 meters. So we substitute in our formula and we'll have a quarter times 22/7 times 3 times 3. That will give us, if we use our calculator, so this will give us, using the calculator, this will give us 7. That is to 2 decimal places. That will give us 7.07 meters square. So that's how we calculate the area of a quadrant. What about the area of a semicircle? We calculate the area of a semicircle. A semicircle, this is a semicircle, and we are given the diameter. Sometimes you are given the diameter, not the radius, and you are told to calculate the area. What are you going to do? So again, remember to write the rule. A half, because this is a semicircle, we write a half pi r squared. What then is our diameter? I mean, what is our radius? Our radius, we normally divide diameter by 2. So if we divide the diameter by 2, we'll have 2.5. That will be our radius. If we substitute, then in our formula, we have a half times 22/7 times 2.5 times 2.5. If we use our calculator, this will also give us you've got to check the units correctly. So this is kilometers, then it will be kilometers, 9.82 kilometers or square kilometers. That is the semicircle. And we have said you have to divide the diameter by 2. That is very important. If you are given the radius, the area, and you're supposed to find, you're given the area and you're supposed to find the radius. For example, so if you are given A is 10 and you are not given the radius, you're told to show that it is 1.78. So what we are supposed to do, we substitute 10 to A. In place of A, we put 10. So you find the square of this value here. Using your calculator, you realize that you'll find the radius is 1.78. So to that, then we come to the end of our lesson today. But before we do that, let us remind ourselves what we learned today. So again, we learned about the area of two-dimensional objects or shapes. And you learn that the area of a parallelogram is given by length times base. The area of a rhombus and a kite is a half times diagonal x and y. And the area of a trapezium is a half height times a plus b, which are the opposite sides of the opposite parallel sides of the trapezium. Again, we have learned the area of a circle, and we have realized that to find the area of a circle, use the formula pi r squared. If it is a half of the circle, then we put a half to give us a half pi r squared. If it's a quadrant, which is a quarter of the circle, then it becomes a quarter pi r squared. Thank you.